All right. Last two, and it's really this example and then explaining something that happens in this example. So we're starting the same exact way. We're looking for a full GCF from all four pieces. And the number that's going to go into all of these is 3. So we're going to divide that 3 out of each of these and see what we're left with. And we should get 2b to the third minus 3b squared minus 8b plus 12. All right? And then we're going to get into our grouping. So we're going to look for a GCF from these two, and then look for a GCF from these two and divide them out. So 2 and 3 don't have any sort of number that goes into both of them. There's no GCF there, but they both contain up to 2b, so we can do b squared. So if I factor out b squared, I'm left with 2b minus 3. And then the next one, this first term is negative, so we're going to factor out a negative. And then 8 and 12, 4 goes nicely into each of those. We're going to take out a negative 4, leaving us with 2b minus 3, because that'll switch its sign. Awesome. And then again, we hoot and holler and get really excited because this piece and this piece are the same. So one of our factors is 2b minus 3. Our other factor is b squared minus 4. And we're going to remember to bring down this 3. Now, normally we would be done, but because something else happens in this type of factoring, and it's the type of thing that the Algebra 2 teachers has really said they want to point out, I want you to start recognizing this situation right here. A perfect squared minus a perfect squared. They always need to be perfect squareds, even though technically you can deal with them without, but that's what we're looking for, and it has to be a minus sign. This is something called conjugates, and it can be broken up. Okay, so we're going to bring down our 3, we're going to bring down our 2b minus 3, and then this is going to split into 2 pieces, and one's going to be plus and one's going to be minus, and then you're going to square root both of these. So the square root of b squared is just b, so that goes in there, and then the square root of 4 is 2, so you'll have a 2 in each of here. So these are called conjugates, and the 6th problem on here is just a conjugate so we can talk about it, okay? And I want you to start recognizing these. These are a really awesome shortcut that when you notice them, you can really get an edge, and that's what this is about. So the key here is we're looking for perfect squares. Awesome. Meaning what number squared are. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, and then going back to starting where we had a multiplication table, these are the numbers that show up in the diagonal on the multiplication table that you have. So you have a nice little visual for it as well. Okay, these are the numbers you're looking for, and it has to be a subtraction sign, okay, for this to work. And what's nice is it always breaks down into 2 factors. You always have a plus, you always have a minus, and then it's the square root of whatever you have there. So 4 squared is 2, x squared is x. And then we're going to do the same thing with 25. The square root of 25 is 5. So we've got 5 and 5. So I just want you to start recognizing these. We're going to start bringing them up. You'll see more of them next week as well, okay? And really taking note of these perfect squared numbers is going to help you a ton. And then if you want to really impress your teacher, when you have 2 things like this, where they're identical, but one is a plus and one is a minus, the word for that is conjugate. These are conjugates, okay? Conjugates. That is the key, and you will really impress those Algebra 2 teachers with it, so make sure, take note of that one. Okay? Awesome.